So, what I want you to do, we're going to just practice by making some factor trees. You need to make your factor tree in the way I'm about to describe. So, if you remember factor trees from back in third and fourth grade, you have the basic concept of what to do here. Just I want you to organize your answer like I'm about to do. So, what you do for a factor tree is you want to figure out two numbers that go into 18. And the trick here is to figure out the smallest number that goes into 18. It should be a prime number. So remember, a prime number is any number that's only divisible by itself and 1 is not a prime number. So the prime numbers go 2, then 3, then 5, 7. Those are prime numbers because there's not anything other than 1 times 5 that gives you 5. But 4 is not a prime number because 2 times 2 is 4 and 1 times 4 is 4. So what you're going to test first will always be 2. So if you look at your number, 18 is divisible by 2. So you're going to put the smaller number to the left. That is important. Put the small number to the left. So 18 is 2 times 9. If you organize your factor tree this way, you will always be breaking up the number on the right side. The left side cannot be broken up because it's already a prime number. So then for 9, the smallest number that goes into 9, it's not 2 anymore. 2 doesn't work. It'll be a 3. So 9 is 3 times 3. And you are done. So the prime factors of 18 are 2, 3, and 3. Let's try with 420. Let's do some bigger numbers. So 420 is an even number. So the biggest or the smallest number that goes into 420 is 2. 2, if you do 420 divided by 2, you'd get 210. 210 is still even, so it will be divisible by 2. And if I divide that by 2, 210 divided by 2 is 105. Okay. Now 105 is not even, so it's not divisible by 2. So the next prime number is 3. And if you do 105 divided by 3, it does go in evenly. It is, let's see here, 35. Okay, so now I have 2, 2, 3. 35 is what I want to break up. It's not divisible by 2. It's not divisible by 3. So the next prime number is 5. And 35 divided by 5 is 7. So the prime factorization of 420 is 2 times 2 times 3 times 5 times 7. So if you multiplied all of those numbers, they would multiply up to 420. These are like the leaves of your factor tree. Okay, let's try an even bigger number. So 900 is even, so it will have a 2 go into it. 900 divided by 2 is 450. That is still even. So 450 divided by 2 is 225. That is not even. So you would try 3 in your calculator. If you do 225 divided by 3, that does come out to be an integer, no decimal. That will be, let's see here, 27, 75. Is that right? 75? Yep, that's right. Okay. 75, you check 3 again. 75 is divisible by 3. So you get 3 and 25. Then 25 is not divisible by 3. So the next prime number we would check is 5. And 25 is 5 times 5. So my prime factorization is 2 times 2 times 3 times 3 times 5 times 5. Okay, so next on your notes, I have just kind of a quick how to simplify square roots. So it says your step 1 is going to be to make a factor tree, which we just did. You need to use the same organization that I did above. And then we're going to circle some pairs of numbers. And then we're going to have some of the numbers escape and some of the numbers will disappear. I'll explain this in a second. And then the numbers that are not circled will stay under the square root. So let's start. Let's try square root of 27. Step number 1 said to make a factor tree. So the smallest number that goes into 27, it's not even, so it's not 2. The next number you check is 3. It is divisible by 3, so 27 divided by 3 is 9. And 9 can be broken up into 3 and 3. Okay, so the whole thing with the square root is it wants to figure out, like, the square root of 9 is 3 because 3 times 3 equals 9. So you're actually going to be able to take the square root of 9 out of this square root. So the square root of 9 is 3. That's going to end up coming outside of your square root sign. So that's why we can do the method that I'm just going to do right here. So that we made our factor tree. I'm going to underline the prime factors of 27. Okay, then we're going to circle pairs. It doesn't really matter if you circle these 3's because those make a pair, or if you circle these 3's over here. So everybody always forgets this last prime factor over here, the 1 all the way to the bottom and to the right. So don't forget that one. So what's going to happen is when I factor this, I can take the square root of 9, and it's 3. So one of these 3's is going to disappear, and then the other 3 will end up outside the square root. And then inside the square root is this number here because it's not circled. Okay, so that 3 goes here. So the square root of 27 equals 3 root 3. Okay, let's try with a bigger number. So with 360, we start with the factor tree. The smallest number that goes into 360 is 2. So it's 2 times 180. Then 180 is still even, so it's 2 and 90. 90 is still even, so it's 2 and 45. 45 is not even, but 3 goes into it. 3 and 15. And then 15 is 3 and 5. Okay, let's try now to circle our pairs of numbers. So you'll notice there are 3 2's, but you can only circle a pair, okay, because we're doing a square root. So the exponent we're dealing with here is squared, which is an exponent of 2. So I'm going to circle 2 of my 2's. I also have a pair of 3's. And then I have this 2 and this 5 that did not get circled. Okay, so inside my pairs, you can cross off one of these numbers. And so on the outside of the square root are a 2 and a 3. So I'm going to put 2 times 3 on the outside. Then inside the square root are the numbers that didn't have a pair, so the 2 and the 5. So that gives you 6 root 10. After you multiply. And that's it. Let's try the next one, an even bigger number. So 4320 is divisible by 2, and that will be 2, 1, 6, 0. Yep. 2160 divided by 2 is 2 times 1080. Oh, this is a big one. 1080 is 2 times 540. 540 is 2 times 270. 270 is 2 times 132. Nope, that's not right. 135. Yeah, 135. Nope. Okay, so now 2 is no longer going to work, but I'm running out of paper. So I'm going to move this up to here. So 135 is going to be up here. Okay, 135 is going to be, let's see, your 2 doesn't work. If I do 3, 3 will work. So that will be 45, which is 3 times 15, which is 3 times 5. So that one is a long factor tree. So just before I get started, so I don't get confused, let's underline all my prime factors. So all the 2's running down the left side of the factor tree here, and then these 3's and that 5. Okay, so the next step is to circle your pairs. There's a pair of 2's right here. There's another pair of 2's. And then this 2 doesn't have a partner. I have a pair of 3's. I could have circled this pair or the 2 above. That's fine. Okay, so on the outside of my square root, it looks like we have in each pair something gets canceled out. So we have 2 times 2 and a 3. Those are all on the outside. On the inside, we have a 2 and a 3 and a 5. So multiplying these out, 2 times 2 is 4, times 3 is 12. And on the inside, 2 times 3 is 6, times 5 is 30.